Imagine a world where gravity is so intense that even light struggles to escape, a place born from the violent death of a massive star. This isn't science fiction. It's the mind-bending reality of a neutron star. Today, we're diving deep into the most extreme environment in the universe to answer a truly wild question. What would really happen if you attempted to land on one? Get ready, because this journey will stretch your imagination to its absolute limits. Before we even think about landing, let's understand these cosmic behemoths. Neutron stars are the incredibly dense remnants left behind after a massive star, typically much larger than our Sun, exhausts its nuclear fuel. When these colossal stars die, they don't just fade away. They explode in a spectacular event known as a supernova. This cataclysmic explosion is one of the most energetic events in the universe. During a supernova, the star's core collapses under its own immense gravity. The pressure becomes so extreme that protons and electrons are forced together, transforming into neutrons. This process halts the collapse, creating an incredibly compact object composed almost entirely of these subatomic particles. It's a cosmic recycling program, turning stellar ashes into something truly extraordinary. So what exactly is a neutron star? Picture this. It contains roughly 1.5 times the mass of our entire Sun. Yet all that incredible mass is squeezed into a sphere only about 20 kilometers, 12 miles in diameter. That's roughly the size of a major city like Manhattan or London. This extreme compression makes neutron stars the densest objects in the universe, second only to black holes. The core of a neutron star is a bizarre realm, predominantly made of neutrons. These subatomic particles lacking an electric charge are packed together so tightly that the normal rules of matter simply don't apply. This unique composition gives neutron stars their insane density, defying our everyday understanding of physics. To truly grasp this density, consider this astonishing fact. A sugar cube-sized amount of material from a neutron star would weigh as much as about 1 billion tons on Earth. That's equivalent to the weight of every single car on the planet, all condensed into a tiny, glittering cube. It's a density that is almost impossible for our human minds to fully comprehend. This incredible density is maintained by something called neutron degeneracy pressure. It's a quantum mechanical effect that prevents the neutrons from collapsing further, acting as a cosmic spring. Without this pressure, the neutron star would simply continue to shrink, eventually forming a black hole. Now let's talk about the most immediate and terrifying challenge: gravity. If you were to somehow make it close to the surface of a neutron star, you would experience a gravitational force that is over 2 billion times stronger than what we feel on our planet. This isn't just a little bit stronger. It's an incomprehensible increase in gravitational pull. This immense gravity would have devastating consequences for any spacecraft. Long before you even touch the surface, the sheer force would begin to tear your vessel apart. The structural integrity of even the most advanced materials would be no match for such an extreme pull, effectively turning your ship into a scattered cloud of debris. The gravitational field is so powerful that it warps space-time around the neutron star. Light itself is bent by this gravity, meaning that if you were standing on the surface, you could potentially see the back of your own head, as light from behind you would curve around the star. This phenomenon is known as gravitational lensing, and it's a stark reminder of the extreme conditions. Furthermore, time itself would behave differently. Due to the intense gravity, time would pass more slowly for you near the neutron star compared to an observer far away. This effect, known as gravitational time dilation, means that every second you spent near the star would be equivalent to many more seconds or even minutes passing for someone back on Earth. It's a truly mind-bending consequence of extreme gravity. You might think that perhaps a specialized super-strong parachute could help you descend, but the reality is far more dire and gruesome. As you approach the neutron star, the gravitational tidal forces would become overwhelmingly powerful. These forces are not uniform. The part of your body or spacecraft closer to the neutron star would experience a much stronger pull than the part further away. This differential gravitational pull would stretch and compress your body in a process vividly known as spaghettification. You would be pulled apart into an elongated, string-like shape, much like a piece of spaghetti being stretched. This horrific process would occur long before you ever reach the actual surface, turning you into a stream of atoms. Spaghettification is not just a theoretical concept. It's a very real consequence of extreme gravitational gradients. It's the same phenomenon that would occur if you got too close to a black hole, albeit on a different scale. For a neutron star, the tidal forces are so immense that they would dismantle you atom by atom, leaving no recognizable form. This isn't a quick, painless disintegration. It would be a gradual, agonizing stretching and tearing, as every molecule in your body is subjected to forces beyond comprehension. The very fabric of your being would be unraveled, making any thought of survival utterly impossible. It's a truly terrifying prospect, highlighting the sheer power of these cosmic objects. And let's not forget about the incredibly intense magnetic fields surrounding neutron stars. These fields are not just strong. They are trillions of times stronger than Earth's magnetic field. To put that into perspective, Earth's magnetic field protects us from solar radiation, but a neutron star's field is on an entirely different level of magnitude. The moment you got anywhere close, your technology would likely fail catastrophically. The immense magnetic forces would induce powerful currents in any conductive material, frying electronics instantly. Navigation systems would go haywire, communication devices would cease to function, and any attempt to control your spacecraft would be futile. Even your own body, with its complex electrical signals, would be severely affected. The magnetic field would interfere with neural pathways, potentially causing disorientation, seizures, or even immediate death. It's an environment utterly hostile to both organic life and advanced technology, creating an impenetrable barrier. Some neutron stars, known as pulsars, rotate incredibly rapidly, sometimes hundreds of times per second. This rapid rotation, combined with their powerful magnetic fields, creates beams of electromagnetic radiation that sweep across space like a cosmic lighthouse. If you were caught in one of these beams, the energy flux would be unimaginable. Additionally, neutron stars emit immense amounts of high-energy radiation, including powerful X-rays and gamma rays. These are not gentle warming rays, they are highly energetic particles capable of stripping electrons from atoms and damaging biological tissue at a fundamental level. The exposure to such radiation would take a massive toll on any living being. You would be subjected to levels of radiation that are lethal within moments, if not instantaneously. The cellular damage would be immediate and irreversible, leading to acute radiation sickness and rapid organ failure. Even if by some miracle your spacecraft managed to avoid being obliterated by gravity or magnetic fields, your chances of survival against this radiation would be slim to none. Our planet's atmosphere and magnetic field protect us from the vast majority of cosmic radiation. A neutron star offers no such sanctuary. It is a constant source of deadly particles, bathing its surroundings in a lethal glow. There is simply no known material or technology that could adequately shield a human from such an onslaught for any meaningful duration. This constant bombardment of high-energy particles would not only affect biological systems, but also degrade and damage spacecraft materials over time. Even if a vessel could withstand the initial forces, the long-term exposure to such an extreme radiative environment would quickly render it inoperable. It's a multifaceted death trap. Now let's take a moment here. If you're fascinated by the mysteries of the universe and enjoy diving deep into scientific wonders, consider subscribing to our channel. Hit that notification bell so you can stay updated on our latest explorations into the cosmos. We love bringing you these mind-bending scenarios and the science behind them. Returning to the fate of our hypothetical landing attempt, one must also consider the actual surface conditions of a neutron star. The surface isn't like anything we know. It's likely to have a crust composed of incredibly complex and exotic materials far beyond the elements found on Earth. This crust might be made of a lattice of heavy nuclei surrounded by a sea of electrons. Beneath this crust, scientists theorize the existence of an ocean of neutrons, and even deeper, a core of even more exotic matter. This could include hyperons, strange quarks, or even a quark-gluon plasma, where the fundamental particles of matter are no longer confined within protons and neutrons. It's a state of matter that exists nowhere else in the observable universe, except perhaps in the hearts of other neutron stars. The temperatures on a neutron star are also extreme, often reaching millions of degrees Celsius. This isn't just hot, it's hot enough to ionize almost any material. A landing would not only be impossible due to gravity, radiation, and magnetic fields, but if you somehow did manage to land, you would be met with a landscape that defies imagination and would instantly vaporize anything that touched it. This isn't a solid, stable surface in the way we understand it. It's a dynamic, superheated, and incredibly dense environment. The very concept of landing becomes meaningless in such a place, as any object would simply be absorbed or destroyed by the extreme conditions. It's a truly alien world, hostile to life in every conceivable way. In addition to all these factors, the horrifying reality is that landing on a neutron star isn't just a technical challenge. It's inherently lethal. The combination of unimaginable gravity, crushing tidal forces, intense magnetic fields, deadly radiation, and extreme temperatures makes it an ultimate dead end for any traveler. There is no escape, no survival, and no possibility of return. Every single aspect of a neutron star's environment is designed by the laws of physics to destroy. It's a cosmic crucible where matter is pushed to its absolute limits, and life as we know it simply cannot exist. These objects are fascinating to study from a distance, but they are utterly forbidden zones for any physical exploration. As we journey through these cosmic thoughts, we realize that the universe is filled with wonders that spark both profound curiosity and a healthy dose of dread. Each discovery about these extreme objects leads to new questions and new realms of possibility for theoretical physics. So, as we investigate what could happen if you tried to land on a neutron star, we are reminded of our own planet's delicate balance and the unique conditions that allow life as we know it to thrive. Our Earth, with its gentle gravity, protective atmosphere, and stable magnetic field, is a truly precious oasis in a universe filled with such violent and extreme phenomena. Understanding neutron stars helps us appreciate just how special our home planet truly is and how rare the conditions for life can be. It's a humbling perspective that underscores the importance of cherishing our world. What other cosmic scenarios intrigue you? What other celestial bodies would you like us to explore in such detail? Perhaps the fiery surface of Venus, the icy moons of Jupiter, or the event horizon of a black hole? Let us know in the comments below. Keep your curiosity alive because the universe has so much more to reveal, and we're here to explore it with you. Don't forget to like this video if you found it as mind-blowing as we did. Share it with your friends who love space, and subscribe for more deep dives into the cosmos. Your engagement helps us bring more incredible science to your screens.